Welcome to the 5th NBT preparation session. Today we'll be doing some of the exemplar questions from Euler-Education. Before we begin, it is of utmost importance that when I present a question on the screen, you pause the video and try to solve the question for yourself, and then unpause the video if you get stuck or want to confirm your answer, because that is how learning works. Now, without wasting too much time, let's get to it. The first question says, what is the remainder when 3x cubed minus 5x squared minus 7x plus 20 is divided by x squared minus 2x minus 3? These kinds of questions are very common when you go to university. You'll be doing a lot of divisions, a lot of polynomial divisions in university, especially your first weeks of doing mathematics in university. It is very important that you learn how to divide polynomials. And in this case, we're going to be using long division method. If we are using long division method, apologies for this. If we are using long division method, we are going to have something like this. And what we put here is what needs to be divided. So this is 3x to the power of 3 minus 5x squared minus 7x plus 20. And here we put x squared minus 2x minus 3, like that. So to divide a polynomial by another polynomial, what we need to do is the first step that we need to take is to divide the first terms of higher degree. So in other words, we are going to divide this term by this term because they both have higher degrees. This is 3x to the power of 3 and this is x squared. Here's what we do. Our first step is we're going to say 3x cubed divided by x squared, and the answer that we get here is going to be 3x because x goes and then we're only left with 1x here. So we take this 3x and multiply this right here. So in other words, the answer that we get, which is 3x, we put it on top of this division, whatever it is, and we now take the 3x and multiply x squared minus 2x minus 3, like that. So we're going to get 3x cubed minus 6x squared minus 9x. And then we take this expression and come place it below this one. So this is going to be 3x cubed minus 6x squared minus 9x. So you see this x cubed and this x cubed match up, and this x squared and this x squared match up, and this x and x match up, but the 20 doesn't match with anything. It is always recommended to put a 0 here so that you don't get confused in the process. So, and then you put a negative here because we are subtracting everything. I hope you remember long division from primary school, but what we get here, we need to subtract. 3x cubed minus 3x cubed is going to be 0, so we don't need to write 0 there. Negative 5x squared minus negative 6x squared. This is the same as 6 minus 5, which is going to be just x squared. Negative 7x minus 9x. This is the same as 9x minus 7, which is the same as 2x. And 20 minus 0 is just 20. Now we'll repeat the process again. The process is we now take x squared and we divide it by the first term of higher degree of x squared minus 2x minus 3, and here we'll be left with 1. Remember, we take this number and we put it on top here, so that's plus 1. The moment you have a number that doesn't have a variable, you know that you no longer divide anything by x squared or by the term of higher degree, right? So we're going to take 1 and multiply x squared minus 2x minus 3, and this is just that. So, and then we're going to place this under here. This is going to be x squared minus 2x minus 3, and we put a negative there, and then we see when we find the difference. So x squared minus x squared, they go because they're the same. 2x minus 2x is the same as 2 plus 2x. So in other words, we're going to have 4x. Then 20 minus 3, which is the same as 20 plus 3. So this is 23. So we now have our remainder, which is this one, because we can no longer go on and divide 4x by x squared, right? So which means this is our remainder, and our answer in this case should be A. So let's move on to the next question. What is a to the power of n minus a to the power of n minus 1 equal to? Now, here it's very necessary when you are, especially that you're going to be fighting against time, it is important to inspect the answers when it comes to questions like these. So you try to inspect if it is possible to have a to the power of n plus 1 or a to the power of n minus 1 or a to the power of 2n or something similar to d, right? So in this case, when we look at a to the power of n minus a to the power of n minus 1, it is impossible to add up n and n together because there is a minus sign here. So, okay, let me just write it down. So this is a to the power of n minus a to the power of n minus 1, right? So it is impossible to add these two because of this minus sign. So in other words, we cannot have anything resembling C, right? C cannot make sense because we cannot have anything that adds up the n together. And I don't see another way where we can cancel out the n's and we're left with only n minus 1. It's not possible. So the best way that we can try to do now is to try to factor out one of them and then see what happens to our answer, right? So here's what we have. We have a to the power of n minus a to the power of n minus 1. Now, let's try factoring out a to the power of n minus 1, right? So we can factor out a to the power of n minus 1. In other words, we're going to have this. And then when we look for the first term there, we're going to say a to the power of n divided by a to the power of n minus 1. Right, this will give us this n minus n plus 1 because division means the powers are subtracting. So this is a, and then n and n go. So we'll be left with just a, right? Because it's a to the power of 1, right? So in other words, here we will have a, and this divided by itself, it's just 1. So we're going to have negative 1 here. So which means our answer is D, because look at this. It's a to the power of n minus 1, in brackets a minus 1. So our answer should be D. Nothing hectic. Simplify this expression. I'm not going to say it out loud, but let's try to write it down so we can simplify it, right? So we have a b inside power to the negative 1, and we have a to the power negative 1 plus b to the power negative 1 all to the power negative 1 and close bracket. Let's try to solve this. This is the same as 1 over ab, and before we deal with what's inside, let's first deal with this negative 1, this one. So this is the same as 1 over a to the power of negative 1 plus b to the power negative 1, like that. So this is easier to look at, which is the same as 1 over AB. And now let's come and simplify the denominators. So this is 1 over A plus 1 over B, like that. 1 and 1 will multiply each other, and the denominators will multiply each other because that's the rules. That's the rules of multiplication of fractions. So in other words, we're going to have 1 divided by AB multiplies everything because there are 2 terms in the denominator. So that's 1 over A, and then AB also multiplies 1 over B, like that. So this is going to be A and A goes, and we'll be left with 1 over B plus, and B and B goes plus A. So this is the same as 1 over A plus B, which is A in this case. Now let's move on to the next question. The next question says, what is cos 75 multiplied by sine 60 plus cos 15 sine 30? I find it easy to write the trig identities with smaller angles. In other words, we have cos 75 sine 60 plus cos 15 sine 30, right? So let's try to reduce the angles of these two, right? So cos 75 is the same as sine 15, so we can just write sine 15 here, and sine 60 is the same as cos 30. So, and then this is plus cos 15 sine 30. If you remember the sine compound identity, it says sine A plus B. Sine A plus B is the same as sine A cos B plus cos A sine B, like that. So in other words, we can use this identity to solve this question. So 15 will be our A and 30 will be our B, like that. So in other words, we're going to have sine 15 plus 30, which is the same as sine 45 degrees. And remember your special angles, I think grade 8, grade 9 special angles. If this is 30 and this is 60 and this is 45, this is 45, remember these are 90 degrees. This is going to be 1, and this is going to be 2, and this is going to be root 3. This is going to be 1, 1, and root 2, like that. We are looking for sine 45. So sine 45 is going to be 1 over root 2. So sine 45 is 1 over root 2. When we rationalize this denominator, we're going to multiply by root 2 over root 2, which is the same as multiplying by 1. And we're going to get root 2. Root 2 multiplied by root 2 is the same as 2. So the answer in this case is D. A triangle has an area of 15 square centimeters and a base of 6 centimeters. If the height is 6 centimeters, what is the perimeter of the triangle? Right. So I feel like they gave us the area here just to confuse us, and we are not necessarily going to use the area. But let's assume we have this triangle like this, and we are told that the base is 6 centimeters, the whole base. So in other words, if this is perpendicular, assume that this is the center. In other words, we're going to have 3 here and 3 here, and the height is 6 centimeters, and this is a perpendicular height, by the way. So we are looking for the perimeter, which means the sum of all the sides of this triangle. So in other words, we can use Pythagorean theorem. It's easy as that. So we have 6, 3, and then we're looking for this hypotenuse. And we also have 6 and 3, and we're also looking for this hypotenuse. We just need to use Pythagorean theorem once and then multiply the answer maybe by 2, but it's not necessary. Let's see how it goes. So we have the hypotenuse, let's say 8 squared is going to be 6 squared plus 3 squared, like that. So the hypotenuse will be the root of 36 plus 9, which is the same as root of 45. And root of 45 simplifies to 3, 5, like that. So we know that this is 3 root 5. And this is also 3 root 5 because we just saw that it's 3 and 3 and this is the same height. So these triangles are actually congruent. So these two triangles are congruent, which means their sides, all their sides will be, we have 3 root 5 right there. So now to find the perimeter, we're just going to say this side plus this side plus this side. So this is the same as 3 root 5 plus 3 root 5 plus 6. Remember, we just broke 6 by half and got 3. So this is 3 root 5 plus 3 root 5 plus 6, which is the same as 6 plus 6 root 5. And our answer is A. Just like that. The video is now getting a little bit longer, and I always try to keep my videos short so that you, the viewer, can be engaged as possible. Now you can go and take a break and review whatever we've done, and I'll be uploading part 6 in the following days. So stay tuned for the following video. With that said, we've come to the end of the session, and if you'd like to see more STEM related content from me, be sure to like and subscribe, and maybe share this video with someone who's also preparing for the NBTs. And that's it from me. Remember to keep education fashionable. I will see you in the next one.